Hi everyone, in this video we'll take a look at Rattle. Rattle is a data mining tool for R. It's basically a GUI data mining tool that's kind of like built on top of R that reuses or leverages a lot of the data mining and a lot of the algorithms and various other libraries that are already part of the R ecosystem. So the two key benefits of using Rattle, one from a learning standpoint. So if you're either getting started with R or if you're getting started with machine learning, um, it can be quite a challenge typing a lot of this code and learning through trial and error. And you'll find that R, being a GUI on top of existing libraries, gives you a much easier way to learn a lot of these machine learning algorithms. The other thing really is about from an exploration standpoint. You'll find that Rattle is much more productive. Again, you don't write a lot of code, so you find yourself doing a lot more data exploration through a GUI tool than having to type out everything. So to get started with R, once you have it installed, let's load the library. That's Rattle, and then finally run Rattle again. So once you've run Rattle, again, keep in mind if it's the very first time that you're running Rattle, and you'll find that every time you click on some of the options, it loads the required libraries on demand. So again, when you install Rattle, it doesn't necessarily load all the libraries which it internally uses. So it's very much a on-demand kind of like an installation once you have the initial Rattle UI installed. So each installation, again, there is a dependency on the version of R that you're running and of course the platform that you're using. So you'll find that some of the libraries that are loaded, you might have a bit of a challenge or it might be easy sailing. So again, your specific scenarios might vary, but overall it's a very simple package to work with. The way you can think about how Rattle is kind of like structured is here you have a ribbon-like view, and chances are you're not going to be touching most of this apart from execute. The way it works in R is anytime you change any of the parameters, you will have to click on execute to activate that particular option. So it's not a case that you select a radio button and can switch to a different tab anytime. Specifically, if you've clicked on something or if you're switching between tabs, chances are you will have to execute click on the execute button. And then the way it's kind of laid out is this is kind of linear in nature, and it makes a lot of sense because this is typically how you will work with Rattle. So you will initially load the data. You will want to do some level of exploration and then do some bit of data mashup, and then further you'll want to run some machine learning algorithms using existing models, both supervised and unsupervised. And then finally, you'll want to compare various models, various machine learning algorithms. So chances are you are going to run through these tabs in a linear fashion. So from a UI standpoint and from a user experience standpoint, it is fairly intuitive. So to get started, step one is to get some data into Rattle. So there are a few options here, as you can see. So you can load from a spreadsheet, you can load from a database like MySQL, you can load from an R data set which is in memory, or from an R data file. And then there are a lot of data sets that are available within R. So you could load one of these data sets. Typically, you'll use this when you're learning to use Rattle and when you're trying to run some algorithms on existing data. So in real world, chances are you're probably not going to use this apart from your initial learning or discovery. I find myself using the R dataset, spreadsheet, ODBC, and the R data file most frequently. So let's take a few examples. So again, this is intended more like a hello world example. So to load some data, so let's use some of the existing libraries. So these are the standard data sets that you get with R. As you can see, there's quite a huge list here. And if it's confusing at first, it basically translates to running this command here. So if you go back to the R console and run data, it gives you all the list of data sets that you have available. Again, the list that you see here is of course very dependent on what libraries you have loaded here. So since we have loaded the Rattle library, it should have included that into your list. So here you can see a few of the data sets that you can use while you're learning to use Rattle. So the weather data set is kind of like the hello world equivalent, if you will, of data sets that we can use with Rattle. Keep in mind that the data set that R needs to work with must be a data frame. So that's something you'll want to keep in mind. And finally, again, the other options, popular options, of course, there are options to add data from a spreadsheet, CSV file, Excel files, etc. So to get started, just show you a few examples. And while I'm not going to focus on the R data set in this demo, worthwhile me highlighting why I think it's quite handy or very useful. So anytime you are using R or Rattle, you will most likely use it as a quicker way to explore data. So you'll find that while you may have created objects and data frames within R, and you will use Rattle to do some data exploration. So as a simple example, let me just create a quick data set. So let's just say for talk's sake, I'm creating a couple of data objects here. So let me just use random numbers for now. So let's say 100, and I'll create Y and Z, and then I'll create a data set. So data frame is equal to data dot frame of X, Y, and Z. So now if I open Rattle again, you'll find that let me click on this option again. This time you should find that the data frame object comes up. So again, the prerequisite being that you will want to use data frame, because that's the only format that can be loaded within the data set here. Similarly, any of the libraries you select must be of data frame. So again, this was just a quick example of how you can use data that you are either generating or testing out within the R console, but bringing that into Rattle. But then moving on with the main objective of this video. So let's use that weather data set that we saw here. So the weather data set should be at the bottom. Yeah, so weather. So here we are. This is the weather data set, which is part of the Rattle package. So now if we load that data set again, as I mentioned, anytime you want to take action on one of your inputs, you will have to click on the execute button here. So if I click on execute, what it does is it loads up all the data sets and gives you an initial input facility, if you will, where you can designate the columns, whether it's part of your data input, or in some case the data set may have too many parameters, and some of these are not useful in your analysis, and then you can mark it under ignore. The last thing I'll quickly mention on this tab before we proceed is the target column. So essentially this is a data set which has a bunch of weather-based attributes, and it's also got label data, whether it's going to rain tomorrow. So basically this is the value that we would want to predict. So hence it's marked as a target. So again, there's a lot of flexibility here to kind of either include those attributes, or in some cases, again, it's dependent on the kind of assessment that you're doing. You may want to add certain weightages to certain columns, which will influence how and which particular algorithm you may want to use for the data mining. So step one was to load the data. So mission accomplished. I'll come back to this once we go through the initial first couple of stages, and then I'll explain more about this parameter here. So then what you will want to do once you have loaded the data is, and if you did make any changes to these, like say you may have marked this as ignore, still click on execute, always a good practice. And then let's start exploring the data. So we can run some basic commands here. So these are commands you could have run from the console directly, but having a GUI just makes life a lot easier, a lot less coding, repetitive coding in play. So if I click on execute here, it basically gives you a quick summary of that particular data set. So you can see here it's provided a good summary view here. There's a lot of data that's thrown here, but the general idea being it's basically giving you a summary of that data set. Now, one of the things Rattle's really powerful at is, from a learning standpoint, is keeping an eye out on the log. So you may recall I mentioned that Rattle is basically a GUI layer on top of existing um, R packages and R functions. So as you can see, what it's really doing is it's running the commands that you may already be familiar with, like summary and contents. So just to give you an idea of what's really happening, let's take this data set itself. So the weather data. Again, I'm not doing it in Rattle, just showing it to you on our console. So if we take weather, we show head of weather. So that's pretty much the data set that we are working with. But as you can imagine, if you run these commands directly here, you pretty much get the same experience as what you've seen in Rattle. So that was the weather. So again, it's basically what Rattle is doing is it's running these commands, but it's much more easier both to visually do that as well as it avoids you from having to type a lot of code. So that was basic exploration, but then there's quite a lot more that we can do here. So we can look at distribution. So again, visually look at the data set. So say for example, we would like to view one or more of these variables here in different visualizations. So let's say for example, the minimum temperature, you could visualize it as a box plot. And again, behind the scene, Rattle takes care of generating the required code, and you can see the output back in the RGUI. As well as other common visualizations, like if you're familiar with histograms in R. So again, it makes it a breeze looking at the data set and initially exploring it. So a lot of time can be spent typing these commands in the R console, but using Rattle, it really simplifies your data exploration. There's less coding to do, basically. Finally, there are other explorations that can be done. So, say for example, correlation, quite popular. So, if you want to look at the correlation, and again, whether you're using or interested in using Pearson, Kendall, or Spearman, you can specify that as the parameter. And if you click on execute, it basically creates that correlation view. So, of course, in the console, you can see the actual values here, but it also gives you that graphical, more visual view of the correlation. So if you're not familiar with how correlation works in R or in general, basically it's comparing how one attribute or a variable relates to another, and how they're correlated, whether they're linear or whether they're totally opposites. So again, you'll find that if it is negative value, it means they're not directly correlated. In fact, they could be inversely correlated. If they're closer to -1, it implies that they're inversely correlated, or if they're closer to 1, it implies that it's directly correlated. But then there's a lot of numbers here, and it can be difficult to analyze, which is why visually it makes a lot of sense to display it this way, so you can see how these variables kind of relate to one another. So you can ignore what's happening here on the diagonal here, because it's really comparing the same attribute or variable against both axes. So here you can see anything that's in blue, as you can see, darker the blue implies it's more tightly correlated, and if it is closer to red, it means it's inversely correlated. So as an example, you can see, let's say something that's really dark red, take sunshine for example. So sunshine is inversely proportional to humidity at 3 p.m., which makes a lot of sense. I mean, weather is something that we all understand. If there's a lot of sunshine, chances are there's not going to be a lot of humidity, and vice versa. Whereas some of these, like say for example, let's say, I mean, while this doesn't make a lot of immediate sense, it's really the case where the maximum temperature is influenced by the temperature at 3 p.m. So they're more directly correlated. And then there are certain attributes which really don't have any correlation, as you can see by the voids or the white spaces here. So that gives you a quick analysis of the data using correlation. And then again, there's a few other ways that you can explore the data, but let's just move on. So now that we have taken a look at some of the ways that you can explore data, and again, I have not covered principal component analysis, PCA, in more detail, but maybe set for another video. But once you have explored the data, of course, there are a lot of functions within R to do more with the data as part of a data exploration workflow. But I'm going to skip a few of these and actually move on to cluster. So cluster is another example of unsupervised machine learning through algorithms like k-means clustering. As an example, the data set that we have of the weather, we can run the k-means algorithm to segment it into multiple clusters. So here you can specify the number of clusters that you're looking at. So given that our data sets are relatively small, I don't want such a big cluster. Maybe as an example, only 3 clusters. And you can see behind the scene how the k-means algorithm has been run, and how it's actually segmented that data set into 3 groups or 3 clusters, again based on centrality and various other parameters which are very specific to the k-means algorithm, as well as you have other algorithms at your disposal to do that clustering. The really exciting part about using Rattle from a data mining standpoint is to leverage some of these underlying machine learning algorithms, these models that have been provided by within the R package and other libraries. So a good example again is to start off with a very simple the decision tree model. So it's one of the simplest, but also one of the more effective machine learning algorithms. So if you click on the tree, the decision tree model, and click on execute, it should run that algorithm on the data set. But R also gives you handy functionalities to or shortcuts, if you will, to give you a more visual view of that data set. So if you click on draw here, you can actually see how R's taken that data set and applied decision tree algorithm to actually arrive at that final outcome. So it really has glanced through that data sets, and in this particular case, you can see that how decision tree kind of like works. It's a very visual representation of the underlying algorithm. So here you can see that if the pressure's pressure at 3 p.m. is greater than this value, the likelihood of it raining is 20 of it not raining, sorry, is 20%, and if it is greater than this particular value, there's a higher likelihood. And again, within that, you can see how it's kind of like segmented that. So it's really good example of a very, very simple algorithm like decision tree, and applying that to a data set for quick understanding and for predicting, if you will, based on decision trees. Similarly, you have few other algorithms here, like say, for example, the support vector machine, um, or if we run regression type linear based models, or even things like neural network based models. So as an example, let me also run SVM, or support vector machine, for the model to do this prediction. So again, it's another popular machine learning algorithm. So we can again see how simple Rattle actually makes it for us to run these various machine learning algorithms without writing any code. So once you have run these algorithms, finally it's an opportunity to actually evaluate or compare different machine learning algorithms. So machine learning algorithms by nature may never give you 100% accuracy, but that's one of the trade-offs. So there are a multitude of machine learning algorithms in R. Again, this is just a very small subset of some of the algorithms that you have in R that you can see within Rattle. So then once you run different machine learning algorithms, it's a good idea to use R to evaluate different machine learning algorithms. So given that we have just run the tree and the SVM models, we can do a quick check as to the performance of each of these algorithms. So right now I want to see the error rate. So clicking on execute basically allows me to compare the performance of the decision tree model with the support vector machine based model. So here you can see the overall performance. So given that this is a label data set, it was able to pick up, it was able to compare the actual predictions versus the actual labels. So this is a good point for me to actually go back to the data tab and explain this section here. So this is very specific to you running the data model. So what's happening behind the scene is your entire data set is segmented into a testing, a learning data set, a validation, and finally the actual test itself. Overall, it needs to be 100%. But this is basically how the individual models will segment your data and use different parts of the data, which is going to be random based on the seed value here, to actually run this model. So again, if you run it multiple times or change the seed value, you may end up getting different result sets, but then it's still a good idea to go here and evaluate the data set. So this is a comparison of how the decision tree model fared, and you can see that overall error rate and the predicted value. So here you can see that the actual value was no, but it actually predicted it to be yes 5 times. So again, it shows you some of the error rates for the decision tree model. Similarly, for the SVM model, you can actually see how SVMs fared. So again, it's not really a case where there's a super smart machine learning algorithm. Normally, it has to be taken on a case-by-case basis. It really depends on what your data set looks like, the performance that you need for that machine learning in terms of computation or the time that the system takes to perform that computation, and then finally the error rates. So you can, of course, tweak the parameters, make these changes to ultimately, help you identify what's the best algorithm, the machine learning algorithm that makes best sense for your data set. But overall, R, just shown you R with Rattle. It's a very handy tool to help you in that data exploration. And again, it's always good to look at the log tab here, because there's a lot of things we can learn by looking at the generated code here. So it's almost a case where you get a sneak peek of the code here, and you can repurpose a lot of this code within your actual R application. So I think that's it for this episode. So we've taken a look at Rattle to do some quick data mining operations. We have loaded some sample data sets, in this particular case from library, but of course you could have loaded it from your favorite spreadsheet, or taken an export from your underlying platform, or loaded the data directly from R, and then performed a lot of these data exploration and machine learning algorithms to provide predictive kind of like solutions, predictive analytics solutions for your data. All right, so that's a wrap for this video. Look forward to seeing you on the next. Thanks.